If you've ever looked at a prototype and thought, it works, we're good to go now, this episode is for you. One of the most expensive mistakes we see in hardware actually isn't bad ideas. It's assuming a successful prototype means you're ready for production. So for today's episode, I called it with Paul Adams over at Adrian Technology, and I asked him to talk a bit about DFM feedback, and especially what happens when it gets ignored. Ignoring it or passing it over is not because teams are careless, but because they're under pressure, they're optimistic, they're moving fast. This is normal when we are developing a new product. So Paul's going to talk a bit about a real case where everything worked at prototype level, but multiple DFM red flags were treated as just optional rather than something that needed to be fixed. And the result, issues that were predictable, preventable, and very expensive to fix later. And we're talking, this could even be in the millions of dollars that it could cost you. So let's jump in to understand why prototype success is not the same thing as production readiness, and how DFM is meant to protect you from risk. This is the Sofeast podcast. Let's get into it.
You're listening to China Manufacturing Decoded from the Sofeast Group.
Today we're going to be talking about why ignoring DFM feedback can actually cost you millions of dollars. What I'd like to do is just cover a couple of scenarios. While we've got a customer that tends to ignore what we call red flags. Now, the red flags are actually identified during what we call the initial product DFM. And as we move into tooling, we've got the tooling DFM. Now, DFM, as we all know, stands for Design for Manufacture. And during one of these reviews, we highlighted a number of areas that would and will cause issues from both assembly, from a fit function point of view, as well as in the actual injection mold process itself, whereas causing difficulties from demolding, in other words, getting the part out of the mold itself, which would cause damage and cause deformation, cause scratching on the surface as the plastic part is ejected out. Now, the internal team actually highlighted this to the customer during the DFM in the report. The email was sent to the customer, and the customer turned around and said, yeah, well, that's all fine. However, when we assembled the prototype, we found everything to be perfectly all right. So therefore, please go ahead without making any changes, straight into tooling. So this is an area where it's more like the customer thinks they know best because they have produced and fitted themselves a single prototype. Now, which leads me on to the next thing. Prototypes are there for validating a design, validating the function, but not necessarily in a production method or fashion. Now, this is simply because each of the prototypes comes out, the tolerances are not exactly the same. In fact, they're a lot wider than what we can achieve with injection molding and other sort of mass production processes. And often or not, each of these prototype units is what we call hand-fitted. In other words, there's a lot of manual labor going into each of the components that are going into each of the assembled components. Now, as we know, this is not the case or the desired outcome when it comes to mass production. The idea of mass production is that the parts go together seamlessly, consistently, and the first product is going to be the same as the 10th, the 10,000, and the 10th million product. There may be iterations in between that, but you know what I mean. Basically, it's the consistency of the parts going together in mass production. And that cannot be achieved, or it is certainly not the same as when we come to the prototyping method. So they sort of dropped the ball and missed the meaning of what a validation from a prototype is actually meant to be. Okay, so this is the first thing. Materials is also another thing that needs to take into consideration. When we're looking at materials for prototypes, we're looking at potentially resins or polymers that are not the same as mass production. Now, some of you out there may argue that you can get exactly the same polymer for prototyping as you can for mass production. Well, yes, generally that is the case. However, it's the actual processing itself. In other words, it's got a high pressure injection molding where you've got the finished part is very, very different to the finished part of a same material, but in a prototyping methodology. Okay? Different parameters, different outcome when it comes to bending, strength, impact test, all these other aspects. Not going to act the same. So this is a major issue when it comes to trying to compare your prototype to mass production. They are different beasts. Okay, so that's one thing. Tooling limitations. Now, I did mention earlier that we're looking at some of the issues that were identified in the DFM were impacting the injection mold. And that process requires parts to be ejected. Once they're injected, i.e. the molten material was injected into the tool itself, the tool opens and the ejector pins push out the finished component. Now, if we've got issues with respect to the part coming out, then it's going to deform as it's being pushed out or leave scuff marks on the surfaces as it's pushed out from the actual tool itself. This will and could, or basically could and will, depends on which way you look at it, affect the fit and potentially the function of the sort of product from mass production. Okay? So if you've got two mating parts that require a very tight tolerance because they're a water-type barrier, for example, and we've got scuff marks on one of those surfaces, well, those scuff marks could act as a capillary tube for water, and the water is going to be drawn up through those scratch marks, causing a leak, for example. So, you can't always assume that what we're highlighting as issues in the DFM are easily brushed to one side. That's a big mistake. Let's have a look at the other sort of potential issues that we've got. Is inconsistency in production leads to higher labor costs, higher scrap rates, reworks, and disgruntled workers on the shop floor because there are issues with every single one of these parts going together in a mass production. And this is not good. It's not good for costs. It's not good for morale in the workshop. And it's not good for you as a customer. And basically, you get a defective product every time it comes together. Simply because you got potential stretch marks or a deformation or where parts have been forced together. That's going to damage some of the sort of snap bits or surface finish or whatever the case may be. So again, there's something to look at. Transportation test failures, with slightly damaged products because of the inconsistency or, some of the areas that have been highlighted during the DFM were not addressed during the tooling stage. That could affect how the part fits together. In other words, as the product is dropped or even being transported, vibration, high altitude, low temperature, low humidity, high humidity, all of these things come into effect, which could have been overcome if these issues were addressed during the design stage, in other words, before we go into touring. And of course, once we've got product in the field, in other words, product that you have sold as a customer to your customer base, what's the cost of returns? Okay. So it's a lot more than some of the modifications, which potentially could just be a couple of hours at the start of the design before we go into cutting steel on the injection mold tool. So, you look at $1,000 worth of work up front versus tens, if not hundreds of thousands of dollars worth of reclaims, warranty issues, and not to mention the effect on your brand reputation. So again, for the lack of a day's work, 2 days' work, a week's work, whatever the case may be, could be a huge success versus a failed company because of ignoring some advice to start with, let's say. How do I fix this? Well, it's an easy fix, really. All you got to do is follow the guidelines with respect to issues found in DFM. They're relatively easy to change because there's a CAD change. It could be an effect of draft angles or changing the texture on a certain surface finish, for example. Changing it at the pre-film stage is a factor of one, let's call it. Changing anything after tooling is a factor of 100. In other words, it's going to cost you 100 times more post-tooling than it would have done pre-tooling. Okay, so that's one thing. Let's talk about delays. Okay, delays on the fact that production is not going correct. And when you do it, it's not going correct, well, we've already mentioned you can't actually have a smooth production run. Your products going out the door or issues, failure rates go up, reject rates go up, scrap rates go up, rework rates go up, your reputation goes down. And basically all this rework and everything like this does impact the lead time in order to get products out. So going quick often means the result is a lot slower. Okay. Slower at the beginning often wins the race. Tortoise and hare story. I'm not going to go into that, but you all know that. And that's a very true thing. So if you're looking at rushing to start with and making all of the mistakes because you need to hit a certain deadline for launch, well, there's a good chance you could potentially miss that deadline because you rushed and made mistakes to start with, whereas a couple of extra weeks at the beginning would actually mean that you can hit that launch deadline with confidence. With a product that has spent a little bit more time in review on the design before cutting steel and tooling, etc. Now, how does that impact cost? Well, a lot of companies out there these days rely on investment. So if you are one of these companies that have got an investor or a loan or whatever the case may be, the impact is not just on you as a company, but you have to answer to your investors. Now, I know a lot of investors out there are saying, "Come on, we need to get to market as quickly as possible in order to start selling products, in order to make the money back, etc., etc." Yes, totally agree. Yeah, there's nothing wrong with that. However, like I mentioned earlier, sometimes going slower at the beginning means a quicker win ultimately at the end because you can launch with a good product, reliable product, and you can hit the market on time with a winning product. Okay, so this is where the investor is going to be happy and happy to reinvest or continue investing in growth, for example, in your company. If you bend to the pressure of your investor, often or not, that's not going to go very well because you're skipping or ignoring advice from the experts. In this case, there's a simple DFM review. Ignore those, and you're going to launch with a product that is substandard. Therefore, your investors can say, "Why are we making the money?" Well, we're not making money, Mr. Investor, because we've got all loads of returns, the warranty workers up. I'm not sure we can actually do anything because we need to reinvest in another tool, which is 10, 20, 30, 50, $100,000, whatever the case may be, on your project. It's not going to be that happy. Simply because you're trying to push at the beginning of the project, or pre-tooling, let's say. So let's look at best practices. Now, the best practice is to take the DFM very, very seriously. You need to work with your contract manufacturer. You need to look at what they are saying, take their advice on board, because this is not their first rodeo. It may be your first rodeo, but it's certainly not the contract manufacturer's first rodeo. They've certainly done this before. And what they're saying is generally what goes. And they probably, I hate to say it, but they know best, but yeah, they probably do. So it's important to have that very good relationship, that close collaboration with your contract manufacturer so that you understand and not just push back and say, "No, don't do it." You can ask the questions like, okay, what does this red line here mean? What's the comment mean here? What's the impact on tooling, or what's the best way around this? So it's having a good conversation in order to understand some of the issues that are being pushed back in front of you from a DFM point of view, as opposed to blindly taking it on yes or no. So that's the first thing. It's a good practice to bear in mind. Another one is to involve the contract manufacturing engineers as early as possible in the development stage. Here at Agilent, we do that all of the time. We've got the core team, generally led by a senior engineer or new product development lead, with a designer from mechanical side. We'll have the industrial design team on board. We'll have someone from electrical, and we'll have someone from software or firmware if your product requires, all part of the core team. And on top of that, we've got quality and the production engineers involved at a very early stage. And it's important for you as a customer to understand who your core team is, such that you can ask questions and ask sensible questions. You'll get sensible answers back. And it's not just a one-way streak where your contract manufacturer is going to run away with your design and just, throw it over the fence when it's done. This has to be a very close relationship, a collaborative relationship, where it's a two-way thing. Everyone needs to be a win-win. So if we're developing a product, the contract manufacturer is developing a product that is solid and stable, where all of the aspects have been addressed, then we know that the contract manufacturer will be able to produce the part and consistently in mass production. Ultimately, that means a win-win situation, because you as a customer will be able to get a product that you can sell to the market that you know is going to be right first time. Okay? So, which is always good. And like I said, don't work with any contract manufacturers that will work in a bubble and just throw the product or idea or CAD files over the fence when they're finished without discussing anything. That's a big red flag when it comes to choosing your contract manufacturer. So that's one thing. And also make sure that you're working with checklists. Okay, one of the things that we have here is our MPI process is basically a massive checklist with respect to each of the new product introduction phases, goes through where we are making sure that we are ticking all of the boxes. Now, each of these boxes is a defined process that allows us to ensure that we are cross-checked that we are doing what we said we're going to do. In other words, a structured process. Now, if you're working with a contract manufacturer that does not have a checklist or an MPI process in place, then that's a red flag. And because maybe they won't do the DFM, or maybe they won't provide pieces of information back to you where they should be. But the key thing is ask for any pushback. Don't ignore any pushback. Okay? Don't ignore it. And don't ignore advice from the contract manufacturer. Because like I said earlier, a contract manufacturer's job is to design, develop, and produce multiple products, including yours. So they know exactly what they're doing. But you need to make sure that they have a checklist or a process that is stable and in place. Okay? So let's recap. DFMs are there to catch ideas or catch issues, issues that are resolvable before it goes to tooling and into mass production. Okay? Do not ignore the advice from your contract manufacturer. It's there for a reason, and that reason is to ensure that the product is made first time, right time, or the right first time, and it's sustainable in mass production. Okay? So please don't ignore that. And if you don't know what DFM is, reach out to us, because we can walk through, and we've got a number of different examples that we can share with you so you can understand what to look for, how to understand it. Maybe we could do a video on the ins and outs of a DFM from both a design point of view as well as a tooling DFM. Okay, so that's my lot. I'm going to wrap that up now. Thanks for listening. Bye.
Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.